Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, with another special report on earthquakes in California. We are right now having an earthquake swarm strike the Coso Volcanic Field, and this is near the Garlock Fault. In fact, this is continuing a sequence of earthquake swarming that we've been seeing since July. So, as many of you know, we had an earthquake that was quite significant strike the Frazier Fault Junction. So this is Frazier Park, right where the San Andreas and Garlock Fault meet, right here. And then a day later, we had another significant earthquake and an even bigger swarm, much bigger swarm strike here where the Garlock Fault has a little jump in it. And this is Johannesburg. Now we're seeing a earthquake swarm start up here on the eastern side of the Sierra Nevada. And so there's a very clear sequence of events here of how the earthquake swarms are migrating. And we can also just simply look at the fact that we've had 3 earthquake swarms now in less than 2 months. And this isn't necessarily looking all that great for California. These sort of earthquake swarms, while they're lower in magnitude, they load the faults all around the area with more energy. And it's also notable that this is happening at the key fault junction between San Andreas and Garlock and the southern part of Sierra Nevada. And if you look at California as a whole, the Sierra Nevada really is almost like a geologic anchor for California and for the western part of the United States. Though once you go to Oregon, Washington, it gets a little different. But this is all created as a result of the subduction that used to be occurring off the coast of California. Well, that subduction zone got gobbled up. This was the old Farallon plate, still exists, though now it's known as the Juan de Fuca plate here to the north and the Cocos plate here to the south. There is an old remnant plate that is directly underneath North America here. And the San Andreas is very interesting, the fact that it's hypothesized. They think that as that subduction zone went down, basically there was a rift, an oceanic rift that was subducted down. The two kind of canceled each other out and became the transverse transform fault junction that we see now. And it's the largest, as far as I know, I mean, just looking at the map, it's pretty clear. It's the largest transform fault junction for the Ring of Fire. So there's some interesting implications with that. And we're going to talk a little bit later in the video about how California seems to be a stress relief valve for other parts of the world when there are big earthquakes. Because if you look at the timeline for all the biggest earthquakes in California, San Andreas, and we even include the 1868 Hayward Fault, magnitude 6.8, there's always been exceptional activity clustered around those dates. So not just, high activity, but like exceptional, historic, record-breaking, etc. So today we're going to cover what's been happening with these 3 earthquake swarms, what this could mean for California going forward. Right now we're in the middle of eclipse season, so we had a total solar eclipse just back on the 12th of August. We have a partial lunar eclipse coming up on Thursday, the 27th of August, visible from California. The entire partial lunar eclipse will be visible from California. We're actually throwing a watch party here in San Diego. If you would like to attend, then you can check out the lunar eclipse video I made for more information, or you can click the RSVP link in the video description. There's more info there. I'll put that once the live stream is live. The info is ready though on that lunar eclipse video, which I recommend you give a watch. So we're in eclipse season. We have just had 2 M-class solar flares back to back strike. And as a result, there have been radio blackouts over North America and the Pacific Ocean. California has been on the receiving end of both of those M-class flares. Those sunspots are exactly Earth center and direct over the next few days. And so we could get a big solar storm to launch our way. As a result, we had the full moon, of course. That is the partial lunar eclipse. It's a full moon that passes into Earth's shadow. That's on the 27th. We have the superior conjunction of Mercury and Mercury Cazimi on the 27th. As well. So there's a classic energetic convergence that's happening right now. And we also have this really crazy heat dome and heat wave that's striking Southern California, where a lot of this earthquake activity is happening. I mean, right now I'm sweating bullets in my apartment. I don't have AC. So keep that in mind as I do this live stream, please and thank you. But there's just a lot of factors at play right now. This super El Nino is building, wave action in the Pacific, the eastern Pacific off the coast of California, Baja a little to the north, right? It has been much choppier and stronger than normal. We're having a lot of tropical storms and hurricanes develop in the Pacific. So yeah, like where this all goes, I don't know, but this is just looking at it and feeling into it. It really is pretty much the perfect time for something to strike. If it was going to hit, now would be a good time. It would all make sense in hindsight. Be like, ah, yeah, of course we had the earthquake in September of 2026, right? That's not saying it's going to, but it all would make sense. So let's zoom in on what's happening here. Our newest earthquake swarm. This is the Coso Volcanic Field. And this is actually occurring within the China Lake Naval Weapons Center. So you see that right here, weapons station for the Naval Air Weapons Station China Lake. So when I first saw this, I was wondering if these are like explosion pits or something. I was really kind of confused as to what I was looking at here, because they do munitions testing and more, but these are old cinder cone volcanoes. And so this is an active volcanic field. There is magma underneath the surface in some of these locations. So this very well could be a magmatic related swarm. But there are some big faults running through here, as you can see. This is occurring right in the middle of these fault zones. And if we go back to our swarm here, I've selected earthquakes in map area. So we only see the past week of all magnitude earthquakes within this map area. And we see that it is at 240 earthquakes. So this is a big earthquake swarm. If we switch this to largest magnitude, we see magnitude 4. So that's a big earthquake, magnitude 4. Now this is not magnitude 7 or something, but that's, you know, what helped get this swarm started. But in fact, if you go further back, we see that we had some preliminary activity. Well, actually, we're not really seeing anymore. Back on the 17th, 18th, there were some little earthquakes. The swarm really got started on the 20th of August. And then the 21st continued on. See, the 21st is when it really started to ramp up in terms of numbers. And then the magnitude 4 came after there had already been dozens of earthquakes. So it was not just simply the magnitude 4 burst and then all the earthquakes, aftershocks followed. This is really a swarm that's been building. And today is August 24th. So that magnitude 4 was just a little bit more than 24 hours ago as I filmed this. Could be a bigger event coming. If it is volcanic in nature, that's not necessarily guaranteed. And if it is volcanic in nature, that magnitude 4 is quite significant. Keep that in mind. Magnitude 4 earthquake for a volcanic system, especially one that's like this. This supplies a lot of geothermal energy for Southern California, by the way. It's one of the largest geothermal fields in California. So magnitude 4 is quite significant. But what I find really interesting about this is the sequence and the progression of how these earthquake swarms have developed. So let's look at our other map here. This is going back to July. Actually, it's going all the way back to June if I have this set right. Let me see. You go to oldest first. Yeah, this is going all the way back to June 1st, but really we're interested in July and then going on after that. So we're going to zoom in here to Frazier Park, right at that junction of the Garlock and San Andreas Fault. And we didn't really have a big swarm here, okay? You see that for this entire map area, part of which I'm covering, 49 earthquakes, okay? And there's some distribution in that as well, all right? But if we really zone in here, there's our magnitude 4.1. Some geophysicists from the Southern California Seismic Network, they said that was on the Plato Fault, which is kind of an interesting fault right up here. And well, not that one specifically. It's kind of, either way, I'm not so sure it was on the Plato Fault. It was 13.1 kilometers down. So the Plato Fault is kind of slicing in like this as possible. But regardless, when you're right at the junction of the major plate boundary and the Garlock Fault, every other fault nearby is of course connected into that and part of that larger governing system. So you had a magnitude 4.1 at a clear, very important fault junction between the San Andreas and Garlock faults. That was on the 12th of July, as we see, and we don't see any magnitude 3 aftershocks. Okay, so 4.1 and then everything else is 2.9 or lower. But then the next day, we go over to the east here. Look at how the Garlock Fault has this leap. So you have one strand of the Garlock Fault there, very clearly delineated by the mountains, right? These fault scarps here, very clearly delineated by that. And they've actually used some of these fans, these alluvial fans and fault scarps to help date historic activity on the Garlock Fault, because they're going to be offsets in these structures. Well, we see that right around Rancho Seco here, Rancho Seco, there's a jump, okay? So there's a little discontinuity. That's normal, that's fine. Faults aren't completely linear, 100% normal planes. You know, there's a little bit of variation to them. But then we see that on the 13th of July, magnitude 4.3. Also a magnitude 4.1. That was a month earlier in June, right? So a bit of a foreshock to that 4.3. But we see most of the activity was clustered with the 4.3, though actually if you look here, 3.6 was on the 17th of June, the 3.3 was on the 2nd of July, 3.2 was on the 4th of June. So this area has just in general been active, but that 4.3 came after the 4.1 Frazier Park. And in general for this area, as we see, 468 earthquakes in the map area. So there's also this little swarm up there. It's like 20 or so. If we really zone in right there, 455. So let's call it 450 earthquakes in this swarm since June of this year, 2026. So this has been a big release of seismic energy. Most of that energy coming from the 4.3, but you add in the 4.1 beforehand, and this is clearly the largest area of seismic release for these three swarms. But funny how at that you had that happen right at that junction, and now we get this swarm occurring to the north, kind of the next section over where the Sierra Nevada starts to really bend. So if you go here, you notice these there's quite a lot of earthquakes in these faults, but the magnitudes aren't that high, 2.7, 2.2, and they're distributed. You don't have a high density of them all in one location. Whereas these swarms, when you're zoomed out, it just looks the same as everywhere else. But when you zoom into it, then you see a very high clustering of earthquakes. So 265 earthquakes basically in this map area right now, magnitude 4 being the strongest. This was an extensional earthquake. So we can go here to the event page, but mostly strike slip. But if we look at our moment tensor plot, we see that our two solutions here are fairly close to 0 or 180. We're looking at the third number, which is the rake. And so if it's 0 or 180, that means it's a strike slip quake. But because there is a little bit of a negative value there of about -15 for both, that means that there was a little bit of extension with this. So strike slip, but a little bit of pulling apart at the same time. The slope on these, both solutions have the same fault slope of 75 degrees, so fairly steep. And so yeah, this is a notable earthquake swarm that has developed, and I really think it's important to point out because it's now continuing this trend. That's the thing. It's now following the progression that we've seen from Frazier Park and over here in the middle of the Garlock Fault. So this is very clear, 1, 2, 3. Now if we zoom all the way out, I have a box drawn around Central and Southern California, all right? So like this, I don't have Northern California in there. We see that these earthquakes are the biggest that have been striking during this entire time frame, the last 3 months, June, July, August. 4.3, Johannesburg, 4.1, Frazier Park, there's a 4.1, Johannesburg, there's our Coso Junction in the Coso Volcanic Field, 3.8 down off there in Nevada, so that's not California, it's Nevada, 3.8 there, and also that's kind of close by, but not California specifically. And then we get 3.6 once you start to get further down. So these are the biggest earthquakes for Southern California for the past 3 months. And they're not magnitude 5 or magnitude 6 shakers. Those are quite rare, actually. If you really total it out, they're not that common. So this is why we have to pay attention to these magnitude 4s, because they may be the only warnings that we get of maybe something bigger coming. And right now, the conditions are effectively perfect for it. Let's check out our space weather. So here we see our X-ray flux for the past 3 days. And we see 2 M-class flares have just popped off. One of them being a 1.7 M-class flare, nearly 1.8, and the other one being a 1.9, almost a 2.0 M-class flare. They always round down the lower number. That's how that works. So you may say, why not average it to 2? They round down the lowest number. But if we go to our 7-day, we see that this is actually continuing a streak of solar flares that we've been having. And we were wondering if we were going to get more activity, because recently, the past few months, these sunspots have suddenly grown and flared. They've only been active for like 3 days. And we had a 3-day window basically right here. Well, they bucked the trend and now they're flaring again. And we could get some X-class flare activity. This is a pretty significant sunspot. We can check it out right here. 4, 5, 1, 3. There are other sunspots nearby. But you'll notice at the very end, this central core is almost pushing inwards. Where typically, if you watch here, see how they spread apart? That's what's normal with these sunspots. The solar flux, as it pushes out, the sunspots spread out, and that reduces their complexity and it makes them less likely to flare, unless maybe they're to bump into something else. Well, this guy's all twisted up, churned up, and it kind of has this inward drift right at the last moment. And well, that could be explaining these solar flares, which have been giving us radio blackouts over California for the past, 12 hours or so. We can look at our DRAP model that shows us these solar flares. And we don't have it for the latest one. It's only going up to 50 a.m. Universal Time, okay? So 12:50 a.m. Universal Time. But we see this first one right there strike, basically smack dab over California, Baja, right in between, hitting Hawaii a little bit too. That's the first one. And then this is the sunlit side. That's why this is moving across the map, because the Earth is rotating. You notice these colors up there correspond to the fact that we have higher solar radiation coming in right now from a long duration M-class flare that occurred on the limb a few days ago. Still coming in. So we're not at an S1 radiation storm, but we're about 10% higher than normal with our greater than 10 mega electron volt proton flux. Basically what that means is high energy particles are flying in at 10 times a higher rate than normal, and it really hasn't slowed down. And so the other flare occurred more over Hawaii, but when I saw the flare, it was still light out. And basically, if it's light out when these solar flares happen, you're getting hit by some of that flare. So not as strong of a radio blackout for California, or just in general the west coast of the United States for that second flare, but still the sun was out, it was daylight, and therefore we still got some of that. And this eventually will show that. We can look at our actual imagery of the sun, our SUVI imagery here. So we'll see this directly. We'll see our 2 solar flares, and we may have some solar storms now actually inbound as a result. The first one didn't appear to really launch anything. The second one looks a little different. It looks like it maybe did. So I'll zoom forward. There's our first one. See that? I'll hit play. There's our first solar flare. That's the one that had a really nice radio blackout over California. And the second one is coming up at the very end because it just happened. It's basically coming to a close right now. So there's that second one. You see this big filament right there, this big basically plasma arch right there. Coronal loop. And there's just in general a lot of activity. This is the sort of activity you see actually before a bigger flare. So we could be looking at higher M-class flare activity and perhaps even X-class flares in the days ahead. All of this already is charging up the ionosphere and creating a stronger global electric circuit. This induces stronger electric currents in the ground surface, in the oceans, more vibrations and fluctuations in Earth's magnetic field. Actually, you get stronger plasma convection in the ionosphere. It's really, really interesting. But this could be quite significant because we basically have all the factors now lined up, ready to go. We have the solar flares, okay? we have, let me show you the proton flux. We have our proton flux being elevated. Here's our 7 days of proton flux. It really hasn't gone down that much, which is surprising. It wasn't that big of a flare, but clearly it was significant. Still elevated. We have the full moon coming up. And it's not just a full moon, it's a partial lunar eclipse, 95%. We have Mercury Cazimi. Let me show you Mercury Cazimi that we have. This is a superior conjunction of Mercury. We often see these Cazimis, especially the superior conjunction of Mercury, line up with enhanced solar activity. We're already seeing that right now, in fact. So this is Mercury right there. It's on the far side of the sun. It's showing up very bright as a result, just like a full moon does. You know, our moon is bright because it's reflecting that sunlight. Same deal. The sun is denoted by this white circle. We put a disk over it to block out its harsh light so we can see the dimmer outflow from the corona. And well, on the 27th, Mercury is going to be there, conjunct the sun with the superior conjunction, same day as the partial lunar eclipse. So everything's converging together. Now, that doesn't necessarily mean that California is like on the firing line, but we see 3 earthquake swarms in less than 2 months. And well, it kind of just in general heightens the probability a little bit, you would think. It's just notable activity. Notable activity, and it's worth discussing and really kind of looking. Because we also have this heat wave. Major Southern California late August heat wave is occurring this week. And there's possibly even tropical storm remnants affecting California in September. We just had, we'll look at the satellite map in a second, we just had some tropical storms form actually. There's tons of cyclones right now in the Pacific. It's crazy. Hawaii just got devastated by Hurricane Lala, like really bad. My friends in Hawaii telling me like it's really bad for some people. So we see this graphic here showing mean, maximum, and minimum. And this is percentile difference compared to 1979 to 2020 values. So these are some pretty high temperatures that are being experienced. I mean, typically where I am, right on the ocean, it doesn't really get over 25 Celsius or so. So it's usually always about, you know, mid to high 70s or lower depending on the season, but maximum like high 70s. Well, it's going to be mid to high 80s this week. It's going to be up there. So the thing is that the super El Nino, the strongest ever that we've seen thus far, at least the day we have thus far for this El Nino is the strongest ever historically. Now it's a geologic time frame. That's thousands and thousands and thousands and thousands, millions of years. We can't say that. But for our historic time frame, absolutely record-breaking. It's also humid here. That's the thing. There's tons of humidity right now. So it's not just that we have this heat, we also have more humidity. And it's actually harder to raise temperatures when there's more humidity. So that makes these heat waves even more spectacular because they're not raising the temperature when it's dry heat, it's humid. Much more difficult with all that water vapor there to get the temperature up. But once it is up, it sustains itself. So, how much does a heat wave affect California faults and earthquakes? It's definitely not the main factor, and like it may not even be statistically significant. But I personally look at everything. I think everything's interconnected to some degree. And just when you see a convergence of factors that are anomalous or extreme, that's when you start to pay attention. So this heat wave doesn't necessarily mean that, boom, California is going to have a big earthquake. It's just we see all the other factors there, and we have this present as well. It's like, okay, this makes you, take a second look, basically. So I'll link this this article here if you'd like to read about it. But basically, it's just discussing the heat dome that's building, this ridge, and that there is just a lot of heat, a lot of humidity, and even some hazards. Also, fire hazards. Right now, they're having huge evacuations near Reno in Nevada. Of course, Eastern Oregon got hit hard recently. Tons of wildfires across the world. It's been a really bad year for fires. Here we see our zoom.earth map. So I'll go to satellite view here, and we can see all these storms and disturbances in the Pacific. So this is the remnant of Lala, still tropical storm, fading out after having passed by the Hawaiian Islands and swinging north. Here we have Moke, now tropical depression. It was a tropical storm at one point, never got to hurricane status. Here we have Isel, tropical storm, expected to fade out, but it's off the coast of Baja there. We have this new depression here, not named yet. Another disturbance area there, A little bit of activity now in the Atlantic, but nothing really of note. If you didn't know, Atlantic hurricane season is much weaker during El Nino. So they're happy that they're not getting these hurricanes. Pacific is. Look at the difference, right? All these different areas. We have a category, we have a typhoon right here, Sawdell, in the Western Pacific, tropical depression here. We've had some other guys. This guy's expected to strengthen. Well, it was strong before. Sorry, it was a very strong typhoon earlier. Now it's going to be swinging into China and Taiwan. Just as you can see, the Pacific is very active right now. So think of all the wave motion and how that influences energetic loading into the earth, into these faults and more, because there is a transition between the ocean and the earth, right? There is a transition there. And also, as the ocean gets warmer, it can technically hold on to more salts, and maybe it's even dissolving out some salts from the coastal areas. I mean, it's hard to say. I certainly can't claim that or anything. I'm just kind of speculating. Just we know the physics that as water gets warmer, its salinity can go up. And so maybe that creates more porosity in the fault zones. Fault zones are those preferential pathways for fluid migration and everything. So, you know, there's all these effects simultaneously occurring. And that's why I think it's really worth paying attention right now to what is happening. So California is basically on the fire line, as it always is, but it may continue to defy expectations. It's been quite some time now since California's had a big earthquake. Ridgecrest was the last magnitude 7+ earthquake that struck. But I want to mention some interesting stats here as it relates to historic seismicity, okay? So I'm going to turn on our big magnitude 7 earthquakes here for California. Now, this does not cover all of them, okay? I'm really talking about the San Andreas here. But I looked at the record for these bigger magnitude 7 quakes and big earthquake activity elsewhere in the Ring of Fire and found some interesting connections. So I'm just going to start with 1952 Kern County magnitude 7.5, okay? That was on the 21st of July. Well, you had a magnitude 8.1, the Tokachi earthquake, strike Japan March 4th, 1952. So about 4 months, a little bit more than 4 months before this magnitude 7.5 struck Kern County, Japan had a significant magnitude 8.1 earthquake. And Japan gets magnitude 8s. They get magnitude, you know, there's record 1 magnitude 9.1 on record. But the moment you get up to greater than magnitude 8 for Japan, it's a notable big earthquake. So that was a big earthquake in 1852 preceding Kern County. And then after this 7.5, you also had the record magnitude 9.0 strike Kamchatka near Japan. So interesting about that, right? So you had the 8.1 in here. Then you had the 9.0 right there. That was November. You also had a big magnitude 8.6 to 8.7 earthquake in Assam and Tibet in August of 1952. So that's, now that of course is going to be further in, right? But that's one example of big earthquake activity happening, and then California also gets something. Now let's go through all the others, all right? Because it's not just, we're not cherry picking here. We're looking at all the big magnitude 7 earthquakes. So the next one on the list is 1906, San Francisco. Here's the epicenter right there, magnitude 6. 1906, magnitude 7.9. Some estimates are even that's magnitude 8 or greater, April 18th. Well, you had in 1906, in January, 3 months before the San Francisco earthquake, you had a magnitude 8.8 strike Conception, Ecuador, Colombia. So that's the largest earthquake that we have in record for that area. So that's going to be down here, of course. So big magnitude 8.8. That's a huge earthquake, one of the strongest in the global record. Strike in 1906, 3 months before the great earthquake for San Francisco, 1906 in April. Let's go back to 1812. We had a significant burst of seismicity in 1812. We see that right here, 7.5 on the San Andreas. 8th of December, we have on the 21st of December, 8.1 in the channel there, Santa Barbara Islands. Okay. Well, now, as I've discussed this quite a bit, in 1811, 1812, New Madrid had tons of activity. So tons of magnitude, 7, 6, 5, everything. These are high magnitude 7s as well, some of them in this area here. So the New Madrid fault system, or some people call it New Madrid. But this is an old Rift Valley that was preceding what occurred in California by about 1 year to 9 months, about. Well, you also had in Venezuela a really big doublet strike, just like what happened in June of this year. Those two events, 2026 and 1812, are equivalent. And if you look at the historic record for the globe, these are the biggest events for 1812. So California, New Madrid, Venezuela. All this preceded California. Now, this isn't necessarily a ring of fire, but it's local. So that perhaps connection still makes sense. And it's also not far up north. This is Southern California, so it's closer to all that activity as well, which makes sense. Now let's look at 1838. You may not know about this earthquake. We had a magnitude 7.4 on the San Andreas, 1838. All right, and that's just south of the epicenter of 1906. It ruptured more to the south, but that was a big earthquake. Okay, that was the 25th of June. Well, you had in November of 1837 a magnitude 8.8 to magnitude 9.5. They don't know how exactly the magnitude. This is 1837, by the way. But 8.8 to 9.5, the Valdivia earthquake in Chile, near the location where the 9.5 ruptured in 1960, which is the largest ever on record. So this is one of the largest ever earthquakes on record. November 1837, Chile, magnitude 8.8 to 9.5. And well, just about 7 to 8 months later, you get this 7.4 to strike the San Andreas here. Again, these are all like the most notable and the most significant earthquakes. You go to Fort Tejon, all right, another big one, magnitude 7.9, Fort Tejon, the 9th of January, 1857. And well, you have to go a little bit further back than just a few months, but in January of 1855, New Zealand had its biggest ever earthquake on record, that being a magnitude 8.2 to 8.3. So again, it's not just New Zealand had a big earthquake, it's New Zealand had the biggest earthquake ever on record, January of 1855. 2 years later, Fort Tejon popped off. And that New Zealand earthquake is the most significant of note within this time frame. So basically what that, oh, and one more. The other one to mention is Hayward Fault. So we have to turn on our magnitude 6s here. Some estimates are that the Hayward Fault was a magnitude 7, but magnitude 6.8, 1868 Hayward Fault. Mentioning this because this is one of the faults that's the most overdue in California. Okay, well, in 1868, that was the 21st of October. The Hayward Fault, magnitude 6.8, 21st of October, 1868. You had 3 big sequences occur before the Hayward Fault ruptured. You had a magnitude 8.8 to 9.1 strike Arica, Peru, which again, this is like one of the largest earthquakes ever on record. Okay. That's August of 1868. You then had a bunch of magnitude 7 earthquakes strike Ecuador, Colombia in August, same year. Those aren't magnitude 8s, but worthy of note that there was a magnitude 7 seismic burst in Ecuador, Colombia. And then you also had the biggest earthquake for Hawaii, like on record, 1868. Huge tsunami generated from that. That was caused by the collapse of the flank of Kilauea volcano, which is about to erupt in the next 24 hours or so. But that's estimated at a magnitude 7.7 to 8.0. huge earthquake. 1868, that was April. Biggest ever for the Big Island historically. You had the Hayward Fault earthquake, magnitude 6.8, historic rupture in October of that year. So every single big notable earthquake for California, for the San Andreas, like for the western part of California, right? You notice I'm not talking about these guys to the east, okay? But right there along the Ring of Fire, they're in it, it's happening, it's going. They all basically corresponded with huge activity elsewhere. So what it seems to me, and look at these subduction zones, okay? You have the subduction zones going up. You do have a nice transform fault junction there, but subduction zone, subduction, all the way, basically all the way down. Go here. You have some transform sections here in New Zealand and a little bit south. You have rifting in these areas. South America, all subduction. Mexico, Central America, subduction. It's until you get to Baja, going all the way to Triple Point, that you get this huge transform junction there, where the plates glide past each other like this. So it really seems that when you get these huge earthquakes in other parts of the Ring of Fire, that there is then this kind of corresponding pressure relief valve mechanism that California performs. That's what it seems to me. That's what the historic data suggests. And this is just a metaphor of pressure release, but there's something there. And you can also kind of think about like the meta of this, all right? If you know video games, there's like often like a meta to a video game. Like the designers make a video game, but then how the players eventually they find like the most optimal outcomes of how to play a character or whatever. That's called the meta, right? It's just like the kind of end game of everything. Well, California ate up a geologic plate boundary rift zone and the subduction zone. It's pretty crazy that you had, and that's what's going to happen up here eventually, but you had the plates, oceanic plate being created, rifting apart, then as that met the subduction zone, that completely transformed California into this transform fault junction. So it's very bizarre. It's very odd that a whole plate has been swallowed up effectively. And now we have this very unique fault junction that is very slow to release seismicity, but can go up to magnitude 8, perhaps even greater. And when it goes, it really rocks. But it's quieter than the rest of the Ring of Fire, basically across the board. But if there's big activity elsewhere, San Andreas seems to wake up and basically knock out a magnitude 7+. And these are the big magnitude 7s too, not the 7.1s. We're talking the big magnitude 7.4, 7.5, 7.9s. So yeah, 3 earthquake swarms. All the conditions right now are set. We'll see what happens. But I'll be back with more updates if there's more notable activity to present. But as of right now, no magnitude 5s, no magnitude 6s have been striking in the past month. We hope it stays that way. But if you really had to choose NorCal or SoCal for the next one, the next big one, I'm leaning more towards SoCal. We did have the 5.6 up here, Redwood Valley, for NorCal recently. I feel like that's kind of delay maybe the next big one for Northern California. Overall, there's more energy and strain built up in Southern California. So if you really had to make me choose, I think they're pretty equivalent, but if you really had to make me choose, I would think SoCal is more likely to go next versus NorCal. The bigger question though, to ask is, okay, well, are we still having seismicity to the east, or is it now going to transition to the west? Because if you look at the historic record, you get the big earthquakes that move over into this shear zone, the Mojave Desert and southeastern California, or even further up into like Owens Valley, etc. You get to shift over here, and then sometimes, once this is all done, these ruptures have all done their thing, and now it's in the healing and loading phase, it shifts over to the west. So I'm not sure if we're done with the east yet. Last big one, 2019, magnitude 7.1 Ridgecrest. So is that the last big earthquake to the east for the next, time frame? These are like decadal rhythms I'm discussing. Or do we got more out there? That's a big question, and it's difficult to answer. But I'll keep doing my best. I'll keep updating you all. So just a couple super thanks have come in. Shiny New Day, thank you for the super thanks. OCZ, thank you for the super thanks. And also for this other one as well. So thank you all so much for watching, everybody. I've been your host, Stefan Burns, geologist, geophysicist, space weatherman. Partial lunar eclipse coming up. If you're in San Diego or nearby, then definitely check out the event. It's free. It's in San Diego. It's going to be great. We already have tons of people signed up. So it's kind of like picnic style. So you can bring some blankets, maybe just bring some cold drinks. It's non-alcoholic. It's a public park. But it's going to be a lot of fun. And then as the sun sets, we're going to see the moon rise, and there'll be that partial lunar eclipse. It peaks for us at 9:12 p.m. So it goes from 4 to 10. More information in the RSVP link is in the video description. So thank you all so much. Huge super thanks just came in from KJM. Thank you so much, brother, for that. Or, just thank you so much. And wishing all of you well. Please take care of yourselves. I'll see you all in the next video.